Okay, we're going to do a question where we find the tangent and normal line at a point on a graph. So the graph I've chosen here is not a function so that we can implicitly differentiate. So this is the graph, and I graphed it here so you could see a picture of it. And we're going to find the equation of the tangent and normal lines at the point of tangency 2, 5. So I've shown that as the blue point there, blue dot on the graph. Okay, so the first thing you want to do is find the derivative. So we're going to do this implicitly. So we have 2xy plus x squared equals y plus 19. And we're going to treat this as a product. And remember, implied within every y is a function of x, so we're going to use the chain rule. Okay, so we have first derivative of the second plus second, and then derivative of the first. And then plus the derivative of x squared, which is 2x, equals the derivative of y is dy dx, or 1 times dy dx, and then the derivative of 19 is 0. Okay, so once I have this, I'm going to bring my dy dx's to one side. And I'll minus this one from the right-hand side there. And then I'll bring the 2y over and the 2x over. Okay, and then I'll just move this up here. So then I'm going to factor out a dy dx. And I have 2x minus 1. And then I have minus 2y minus 2x. And then I can isolate dy dx, and I get minus 2y minus 2x over 2x minus 1. Okay, so this is the derivative of this non-function. And I need to know both the x and the y value, which isn't a problem because I gave you the 0.25. Okay, so to find the tangent line, the equation of the tangent line, we're going to need the slope of the tangent, which is the derivative evaluated at the point of tangency. So what we're going to do is we're going to take dy dx, and we're going to evaluate it at x equals 2 and y equals 5. So you can use this notation to do that. And so you get minus 2 times 5 minus 2 times 2 all over 2 times 2 minus 1. So this equals, what is that, minus 14 over 3. So not nice numbers, but so be it. Okay, also what we know is that the tangent line, so I'll draw it up here, I'll draw it in blue. The tangent line looks something, sorry, it's hard to draw a line here, looks something like that, right? So it has the slope, a negative slope of minus 14 over 3, and it goes through the point 2, 5. So we can use the slope formula to get that equation. So 14 over 3, I'll put the minus on the bottom. And then we have y minus, and I can use the y value 5, and x minus 2. Okay, and then we can just multiply both sides by minus 3 and multiply both sides by x minus 2 to get rid of fractions. And we get 14x minus 28, and then minus 3y plus 15, and then I get 14x plus 3y, and then I can bring the 28 over, and what does that give me? 30, 43. Okay, and you can leave the equation of the line in that form, or you can put it in the y equals mx plus b. I'm just going to leave it like this. So this is the equation of the tangent line. Okay, so to find the equation of the normal line, I'll draw it up here. The normal line is perpendicular or orthogonal or 90 degrees to the tangent line. So it also goes through the point of tangency, but the slope is going to be the negative reciprocal. So the slope of the normal line is -1 over the slope of the tangent. So that's going to be 3 over 14 and a positive. So then we can set that up here. So we get 3 over 14, and then y minus 5 and x minus 2, because it goes through the same coordinate or point of tangency, and then you get 3x minus 6 and 14y, and I need to multiply 14 by 5, and I think that's 70, and then I get 3x minus 14y, and then that's going to give me minus 64. And then this is the equation this is the equation of the normal line. So again, the derivative gives you a formula for the slope of the tangent at any point on this graph, and I can plug in the point of tangency to actually get the slope, and the negative reciprocal will give me the slope of the normal line, and then I can use my slope formula to get an equation of both those lines.